Okay, so in this video, we're going to talk about finding the distance between 2 points in the plane. So for the first part of this, I want to go ahead and derive the distance formula. So I want to build it from scratch. Let's pretend we've never seen it before, and maybe you haven't seen it before, but we're going to come up with it naturally here. Okay, so let's say that we have 2 points in the plane. Okay, so we're going to say, we're just going to keep it in the upper right quadrant for now. That's fine. Let's say we have a point that's given by x1, y1, and and have a point 2, which is given by, we'll say, x2, y2. Okay, and we have, let's just draw a line between them. Okay, and we're trying to find the distance between them. Okay. So let's come up with a different point here. Okay, so a different point that's going to allow us to make a right triangle. The right triangle part of this is very important. So if you remember back to maybe high school math, what we're able to do is we're able to pick a point here where we have a straight line from your point 2 over here coming down here, and a straight line going to the right to this point over here. And that's going to give us a nice 90-degree angle between these two. And this is our point C, or our point 3 if you want to, I guess. Okay. We'll say this is point A, and this is point B, and we're going to call this point C. Okay, so what are the coordinates of point C? Okay, so our point C is given by, well, notice that it's going to have the x component of, our point B, so we'll say it's x2, and it's also going to have the y component of our point 1. Okay, so this is where this gets interesting. If we want to have the distance between point A and point C, we could subtract their x components. So we have the distance from A to C is given by x2 minus x1. Okay. So if we want to find this distance, we could just subtract their x components, right? It's a straight line. We don't have to worry about, finding anything overly complicated there. And then if we want to find the distance from point C to point B, we could have, and then C to B is going to be given by y2 minus y1. So we could label this side here, from B to C, we could label this side y2 minus y1. That represents our side length here, and we can label A to C x2 minus x1. That's going to be the distance here. Okay, so if you remember back to high school math, if you want to find the length of this side here, which incidentally is our distance from point A to point B, then you can take the length of this side. We know that the length of B to C squared is added to the length of A to C squared is going to give us the length of A to B squared. So to make this a little easier to digest, I guess, we'll go ahead and call this side Z. We'll call this side Y, and we'll call this side X. And so if you remember from high school math, we have that X squared plus Y squared is equal to Z squared. So hopefully that's a little easier to understand, right? I'm sure we've seen this before. This is the Pythagorean theorem right here, okay? So, but here X is going to be given by x2 minus x1, and Y is going to be given by y2 minus y1, okay? So if we want to find the length of Z, we can just take the square root of both sides, and we have that Z is going to be given by the square root of x squared plus y squared, okay? But X is x2 minus x1, and Y is y2 minus y1. So let's go ahead and substitute those in. So we're going to have Z is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and this is actually our distance formula. Okay, so the distance between any 2 points is given by D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's kind of the intuition behind that. You don't necessarily have to memorize how to come up with this formula. It's good to know that. But if you're going to memorize anything, this formula, this distance formula, the d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, that's one to memorize. This is almost certain to show up on the final, so this would be something that I would absolutely spend time memorizing, okay? So let's go ahead and see if we can solve a couple of examples here. Okay, so here we have the point C equals 3, 0, and the point E equals negative 2, 4. So we'll call C point 1. So this will be x1, y1, and E is going to be point 2. So we'll have x2, y2. So now we're going to use all we have to do is plug in these values in the distance formula. So we have D is equal to the square root of x2 minus x1, so negative 2 minus 3 squared plus y2 minus y1 squared. So we'll have 4 minus 0 squared. Okay, take the square root of that, and we get negative 2 minus 3. We have negative 5 squared plus 4 squared. So this is going to give us the square root of 25 plus 16. Okay. So we're going to have that this is equal to the square root of 41. And I don't think that we can simplify this any more than that. So we have that the distance is equal to the square root of 41. So D equals the square root of 41. Okay, now let's try another one. Here we have A equals 0, negative 9, and B equals 3, negative 6. So here, we're going to say that this is, A is 0.1, so we have x1, y1, and B is 0.2, we have x2, y2. So D here is going to be given by the square root of x2 minus x1 plus squared plus y2 minus y1 squared. So we'll have 3 minus 0 squared plus negative 6 minus negative 9 squared, and the square root of all of that. So we'll have the square root of 3 squared plus negative 6 minus negative 9. That's the same thing as negative 6 plus 9. So we'll have 3 squared plus 3 squared, the square root of that. So that's going to give us the square root of 9 plus 9, which is going to give us the square root of 18. And I don't think we can do anything with the square root of 18. That's as much as you're going to simplify it. So we're going to go ahead and circle that and call that our distance.